Today we're still in Unit 5. We're on Day 6. We're looking at similarity and how it relates to perimeter and area. So we're going to start with number 1. It tells us the rectangles are similar. We can see that because it would have a ratio of 3:2. They want us to find the perimeters and areas of each one first. So remember, in a rectangle, all the sides are congruent. So I have a 3 length here, a 9 here. When I add those all up, 18 plus 6, I end up with 24. Remember, area is length times width, so in this case it would be 27. Let's go look at the smaller rectangle. Again, opposite sides are congruent. When I add them up, 12 plus 2 would be 16. And their area, again, is 2 times 6, which is 12. Alright, so the first thing they want us to do is find the ratio of their sides, so I can pick any side. It says make sure I reduce it, so that first one is a 3:2. If I go on to the next one, it wants the ratio of their perimeter. So I've got 24:16, and again, they want us to reduce it. Well, 8 goes into both of those, and we end up with a ratio of 3:2. Next, they want the ratio of their areas. That would be 27:12. In that case, 3 goes into both of those, and I end up with 9:4. And as always in math, we're looking for some type of connection. So we're looking for a connection between the ratio of their sides, the ratio of their perimeters, and the ratio of their areas. And some of you may notice it, some of you may not. Let's go on to the next one, and eventually we'll come up with what that pattern is. Okay, moving on to example number 2. Again, we've got 2 triangles. First of all, they want the perimeter. Notice the triangle is isosceles, which means both these side lengths would be 10. Both these side lengths would be 5. If I'm looking for the perimeter, I'm going to add up all 3 sides, 10, 10, and 16. I get 36. If you remember, the formula for area of a triangle is 1/2 base times height. 1/2 of 16 times 6, and we end up with 48. Okay, let's look at the second triangle. Again, perimeter, we're going to add them all up. 5, 5, and 8 gives me 18. Again, their area is 1/2 the base, which is 8 times 3, and we end up with 12. Alright, so back here we go find the ratio of their sides, and remember, if these triangles are similar, it doesn't matter what sides we pick. We could pick the 10:5 or the 6:18. Notice in either case, 10:5 reduces to 2:1. Let's go look at the ratio of their perimeters. We start off with 36:18. Again, that reduces to 2:1. Let's go look at the ratio of their areas. That's 48:12. 4 goes into, actually 12 goes into both of those, and we end up with 4:1. And again, we're looking for a connection between the ratio of their sides, the ratio of their perimeters, and the ratio of their areas. Let's go take a look at one more example. If we flip to the back, we're talking about circles. Remember, circumference formula is 2 pi r, and area formula is pi r squared. And I reminded you of those up here. So to find the circumference of this first one, we would have 2 pi times 5, which is 10 pi, and I'm just going to leave it in terms of pi. Here we'd have pi times 5 squared. We end up with 25 pi. Let's look at the circumference of the smaller one. 2 pi times 2 is 4 pi. And then for the next one, pi times 2 squared is equal to 4 pi. Again, we're looking at the ratio of their sides. Well, circles don't have sides, but they do have radius, so we're looking at the ratio of their radii. So that's 5:2. The ratio of the perimeters, remember that circumference, I would have 10 pi to 4 pi. Those pi's cancel out, and 10 and 4 both have a 2 in common, so we can divide that out. And then finally the ratio of their areas, we start off with 25 to pi, 25 pi to 4 pi, and again the best we can do is simplify the pi's, and we get 25 to 4. So again, we're looking for a connection between the ratio of their size, their perimeters, and finally their areas. Let's take a look at a few examples here, and then we're going to try and write it in general terms. If I look at the similarity ratio, the first thing they want is the perimeter ratio. We'll notice in this first example it was 5 to 2 here, it was 5 to 2 here. Let's look on the front side. I had a 3 to 2 here, a 3 to 2 here. Look down at the next one. Again, it was 2 to 1 and 2 to 1. So notice the ratio of their sides is equivalent to the ratio of their perimeters. So if this is a 2 to 3, that means I know this is a 2 to 3. So also if this is 4 to 5, that means this is 4 to 5. Now the bigger question is, how do I get to the ratio of their areas? If you take a look, this is 5 to 2, this is 25 to 4. They are definitely not the same, but there's still a mathematical connection. Flip back on the front and show you that one. Notice this was a 3 to 2, this was then a 9 to 4. We look at the last one, it was a 2 to 1 and a 4 to 1. So again, they're not the same, but by now you might see the connection is we just have to square the ratio. So to get to the area ratio, we take 2 over 3 and we square it, we get 4 to 9. If we go down here, we're going to take 4 to 5, we square that, and we end up with 16 over 25. So finally, how do I get from here back to here? Well, if from here to here I square it, if we want to go backwards, you want to think about the inverse operation, which would be square rooting. Now, 18 and 50 don't have a perfect square, so I'm going to suggest let's reduce them first. 18 divided by 2 is 9, 50 divided by 2 is 25, and now they're both perfect squares. So to get back to the perimeter ratio, I'm taking the square root of 9, the square root of 25, and we end up with 3 over 5, which means their similarity ratio is 3 to 5 as well. Let's take it one step further and let's write it in general terms. If the similarity ratio is A over B, so meaning any value over any value, their perimeter ratio is going to stay the same, and the area ratio is A over B squared, which you also can look at as A squared over B squared. Okay, you have two parts left. One part, there's questions on Canvas that you're going to do. Those include review plus those. And there's one other part in your homework packet. Notice we're skipping day 5. We're not doing any of that because the notes we took on day 6, which is here, these questions we actually did in our notes. So the only ones that I'm going to ask you to do is these at the bottom. It is questions number 1 through 10. And if you notice, they are all multiple choice. I would keep your notes out in front of you. I would probably go ahead and tackle this first, and then you can go back and look at the Canvas assignment as well. Let me know if you have any questions or